All right, so we're working on worksheet 1 and maybe starting worksheet 2 on limits today. We're talking about, yesterday we talked about how we talked about a limit at a particular value. Like, I kind of like this slide, okay? Says what's going on near or close to a particular number, but not necessarily at the number. And then I reminded you that it was a y value. The other thing we looked at y values for over the course of the year was we looked at the end behavior. So we see that this slide, hang on, my cursor issues. Okay, this slide shows that as the limit approaches infinity is talking about the far right end behavior, yes? Limit approaches negative infinity would be the far left end behavior. So we've talked about if it has a vertical asymptote, if it has a horizontal asymptote. If a graph has a vertical asymptote, it's doing something on either side of that, right? Okay. So it could approach positive or negative infinity from the left or from the right. If there's a horizontal asymptote, do you remember what that meant? When we had something like this, and we had something over here, and it ended up doing this. Remember this? The horizontal asymptote was the actual y value that the graph usually approached out on the far left and right. Okay, so that's why it says instead of infinity, it's going to, as we go to the far left, it's going to approach a value, or the far right, it's going to approach a value. All right, that all looks fancy schmancy. Okay, this says that what happens as x approaches infinity is asking about the far right, and it's getting closer and closer to 0, and to 0 on the left. Do you remember those weird laws, or what did we call them? Cases, like for finding the horizontal asymptote or end behavior. The degree of the numerator, remember top heavy, bottom heavy? Is that coming back to you at all? If it was bottom heavy, which this one is, it has 0 x's, x to the 0 on the top and x to the first and the bottom. When it's bottom heavy, it always approached 0. Okay. If it was top heavy, you had to divide it out. Remember that? If it was equal weight, does anybody remember? Leading coefficient over leading coefficient. Does that sound a little bit familiar? Okay. Those rules are still going to apply. Okay. So this one, this part is bottom heavy, so it would approach 0, but what is this going to do then? It's going to add 2 to that. So if you graphed this, it looks like this. If you plug it, it's asking about the left-hand side. So they plugged in really negative numbers, and what is it getting closer and closer to? 2. Okay. Okay. This is something that's oscillating again. And so, well, on the left, you could graph it and put in negative numbers. It's getting tinier and tinier. But on the right, it jumps all over the place. Look, positive, positive, really big number. Oh, negative, really negative number, right? So on the right-hand side, it has no limit. All right, so let's see what happens here. This one is off your notes. It asks about the limit on the right-hand side, x approaches infinity, of 1 over x plus 3. They show a graph of it here. It has a vertical asymptote at -3, but the horizontal end behavior, because it's bottom heavy, is just approaching what? What's the, yes, we go off to the right, the y values are getting what? Tinier and tinier? So it's approaching 0. Okay, so the answer is that the limit approaches 0. All right, you want to try these on your calculator? Or you want to trust me what I've put in? What do you want to do? If you want to go quickly through them so that we can get to the review, I have them on the screen here, okay? So I typed 2x plus 1 divided by x. Then I put in, I use nines, it doesn't matter, right? A million is just one more than 999,999. I just like typing a bunch of nines because I just get to hit the same button. So I put 999, 999, 999. What happens? It's getting closer and closer to 2. Does anybody remember what case this is? Equal weights, yes? And so it's leading coefficient over leading coefficient. Does that ring a bell? Okay. So I'm thinking, looking at this one, it's going to approach -3. It asks about the left-hand side, so I put in -9, -99, -999, -9999, and it was approaching -3. Do you notice what I did here, though? Hang on, sorry. This one, it looks like it actually says it hits -3 right here in my table. But if I scrolled onto the number, do you see what it actually showed? It's just rounding it to -3 to fit it in the table. All right. This one, okay. That's written really weird, isn't it? Usually we'd see 2 pi x. So what's the period here, guys? Good review. 2 pi divided by 2 pi, the period is 1. And what's the amplitude of a cosine graph? 1. Cosine starts at maximum. So this is 1, and where it finishes is 1, and it's just going to keep going, yes? What's happening on the far right? It's going above and below and above and below and above and below. Every point we pick is going to be one or the other, right? But it's going to be either 1 or -1. So we say the limit does not exist. It has to approach a singular value, okay? It can't approach 2 different numbers. All right, what about this one? Again, I typed it in with parentheses top and bottom, and it wants to know the far right end behavior. So I put really big numbers in. What do all these E's mean? Is 6.7 the answer? No, because 6.7 is basically 0.000067, and then it's 0.00000067, which is basically what? 0. It is approaching 0. Does that fit with some of our earlier knowledge about bottom heavy? Do you see that this was bottom heavy? The degree of the denominator is what? Okay, that was a great question. The degree of the denominator. 3. Degree of the denominator. Numerator is 2. So it's bottom heavy. So it approaches 0. That was good. Okay. This is a weird graph. I wouldn't have known what this was going to look like, okay? It's doing some funky business here. But it asks about the left end, okay? So I put in really negative numbers. And what happened? The more negative I put in, the more negative the answer got. So is it approaching a singular value? No, we could say the limit doesn't exist, but it is decreasing without bound, right? Okay, it's going to keep going down, 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 down. All right, 13. This is a weird one. Do you want to try graphing this one, guys? Put your calculator in radian mode. So we have functions in radians, and it is the sine of 2x over x. How do you have to type that? Yeah, when the sign brings up a parenthesis, you want to put the 2x in there, then close parenthesis divided by x. And you could put that bottom one in parentheses too, wouldn't matter. Okay, I'm going to do a zoom trig to start with. That'll set me up somehow. It's not a bad picture. There's a zoom trig. Really weird, right? Okay, it asks what's happening near 0. What does it look like on the screen near 0? It looks like it's getting close to what? 2? How could I go to the table and test that? What's a little bit to the left of 0? 1.99. To the left of 0, anybody? What's just a little bit negative? Negative 0.01. Negative 0.0001, right? Are those okay? What's just a little bit to the right or just a little bit positive? When my checking account is 1 penny, yes, that's just a little bit to the positive. Okay, is it approaching from both of those sides the same number? Yes? What is it approaching from both sides? 2, just what we got, okay. But when I put a 0 in, I get an error. Does everybody understand why that would happen? Can't divide by 0, right? Okay. So, well, it had an error at 0. All these other values were saying it's getting really close to 2. All right. This is an application of a limit. It says the bacteria dish grows according to the function. All right, let's type this bad boy in. Do you remember how many parentheses you need for this? We did these kind of questions. They were called logarithmic or logistic. I think they're called logistic. Does that sound right, guys? 4 divided by the quantity 1 plus 0.35 E, which is second ln, negative 0.2 x, all in the exponent. Okay. And it says graph for 0 to 20. So if I go in and set my x window for 0 to 20, and what are we talking about here? Number of bacteria in a dish? I don't know. I'm going to do y is 0 to, oh, is there a graph paper over there? Ah, it says it goes maybe to 8. That's what the graph paper shows, right? I'm going to cheat and use the graph paper. Okay, I got this graph. Anybody getting that? Okay, my window is 0 to 20 and 0 to 8 or something. I'm in function mode. Who's having trouble? No? Yes? Andrew's still not working? Someone want to check what he typed in? Did it work? Okay. So we're supposed to graph. Where did it start? Can anybody tell where it started? Put in a 0 for me. It starts at 2? Okay, so almost 3. And what's it up to by 20 or 15 or something? Okay, so it's almost up to 4. Okay. Graph we did. After 8 hours, round to the nearest 10th. Can somebody do a trace 8? 3.7, was it grams? Okay. As the limit as it approaches infinity. So apparently this petri dish can only support how many bacteria? Look at my numbers here. I tried 9, 9, 9, 9. Now it's not going to let me trace. I could keep tracing to the right? But that's going to just take a lot of time. So I went to the table and put in a really big number, and it only gets to what? 4. Okay. Do you kind of remember that the top usually told us what it was going to max out at when we did those last semester? All right, one more. What is this called? Exponential growth, or in this case, it's multiplying by 70%, so the value of the car is going down. What did it start at, though? 30,000. So I think our window would have to be 30,000 and going down. Don't let me go more than 5 more minutes on this stuff, okay? Window for X, 0 to 20, and window for Y, 0 to 30,000. Okay. Working for me. Can you figure out the value of the car at 10 years just to help me get a better graph here? And because it asked for B? I have on my little chart here that at 10 years it's 847.43. Is anybody getting that by tracing? Okay, 10 years. Oh, I don't know where that would be. What did we count by to get to 30,000? I don't know, but it's down low. Okay, I'm just going with that. What is the car eventually going to reach? It's going to approach what? 0. That would be the limit. All right. Did anybody try these questions? Do we need to talk about any of them? Let's try 11 for fun because I don't know. You got your calculator in radians already, right? How would you put 11 in your calculator? I think we need like a bunch of parentheses. Like, I think we need a parenthesis at the beginning, then one around this X, and then one at the end, maybe? So parentheses, sign, X, close parenthesis, minus X, close the top parenthesis, divided by X. Yikes. All right, I'm going to do a zoom trig. I didn't get a straight line. Yeah. As it gets close to 0 from the right, well, if I trace and I start at 1 and I get closer and closer to 0, what's the Y value getting closer and closer to? 0. So that seems like a good answer for that one. Is it going to have a limit at 0? It's not going to have a value at 0, but is it approaching the same side, the same value from the left? It appears that it is, right? So the little plus means we're getting there from the right, but it appears that it would approach the same value from the left. All right. Let's just do these because we don't need to graph anything real fast. This will be a good. What is this saying? What is the limit? No, because it's just a -6. What is the limit at -6? It appears that at -6, the graph from both sides is approaching a Y value of 4. Okay, guys, this is on worksheet 1B. Write these down. Number 30, this graph, where is the limit at 4? This would be a great test question. At 4, what is the limit of this function? Almost. Just read the graph paper carefully. Yeah, I think it's -6 because it's counting by -2s, right? But it's not positive anything, right? Because this means as I get close to this, not at, but close to, what Y value am I at? And I believe that's supposed to be -6. All right, over here, limit at 4. Doesn't exist, right? Both sides is increasing without bound, but we usually just say does not exist when it's a both-sided limit. I would take either. It's fine. Okay, this one says at -6, and it doesn't say from the left or right. Definitely doesn't exist there, right? Because one side is going up and one side is going down. So this one you could say it's both sides are going up, but here they're different. All right. To the other worksheet, I have not yet. I'm debating. I think we need to be done. Definitely need to be done. Okay. So tomorrow, some more fun with limits. But today we're moving to number 11 on the review packet. Oh, I said I would do a separate recording, right? Okay. Click here to pause.